Find the linear approximation for the function f of x equals secant x at a equals pi over 3. To find the linear approximation, we need the function, which is secant of x, as well as its derivative, f prime of x, which will be the derivative of secant, which is secant tangent. The next thing to do is evaluate the function f at the a value of pi over 3, which gives the secant of pi over 3. The secant of pi over 3 is 1 over the cosine of pi over 3, and the cosine of pi over 3 is a 1/2, so 1 over 1/2, which can then be equal to 1 times reciprocate the denominator and multiply with the numerator, 2 over 1. 1 times 2 over 1 is 2 over 1, and 2 over 1 is 2. Then evaluate the derivative f prime at the a value of pi over 3, which will be secant of pi over 3 times the tangent of pi over 3. The secant of pi over 3 is 1 over the cosine of pi over 3, which is a 1/2. The tangent of pi over 3 is the sine of pi over 3, which is root 3 over 2 over the cosine of pi over 3, which is a 1/2. Each of these can have the denominator reciprocate and multiply with the numerator, so 1 times 2 over 1, and then times root 3 over 2 times 2 over 1. Which will then equal to 1 times 2 over 1 is a 2 over 1. Root 3 over 2 times a 2 over 1. The 2's can cancel here, and that'll give a root 3 over 1. Multiplying the numerators, 2 times root 3 will give 2 root 3. Multiplying the denominators, 1 times 1 is 1. Anything over 1 is itself, so this will give us 2 root 3. The linear approximation formula, L of x, is f of a plus f prime of a times x minus a. In this problem, a is equal to pi over 3, so this will be f of pi over 3 plus f prime of pi over 3 times x minus pi over 3. F of pi over 3 is here, and f prime of pi over 3 is here. Each of those can be plugged in. So L of x will equal f of pi over 3, which is a 2, plus f prime of pi over 3, which is 2 times the square root of 3, and then times x minus pi over 3. This can be simplified by distributing that 2 root 3 into their x minus pi over 3. So L of x will equal 2 plus 2 root 3x, and then minus 2 root 3 times pi all over 3. This can be rewritten by writing the x term first, 2 root 3 times x, and then the constants next. We have a positive 2 and a minus 2 root 3 pi over 3. It is possible to combine the constants together over a common denominator. It's not required, but perhaps we can write that version down as well. So this will be 2 root 3x plus 6 over 3, which is equal to 2, minus 2 root 3 pi over 3, and then they can combine together, giving 2 root 3x plus 6 minus 2 root 3 pi, all divided by 3. All of that is just a constant of some sort. And there is our linear approximation for the function secant of x at a equals pi over 3.